Okay, this problem says consider the physical quantities S, normally used for distance, V for velocity, acceleration, and T with dimensions. There are the dimensions. The dimensions of velocity and speed are length over time, acceleration is length over time square, and so on. Determine which of the following equations is dimensionally consistent. So if an equation is dimensionally consistent, it has to have the same dimensions on the left hand side as and on the right hand side for it to be dimensionally consistent. Now an equation, even with even it being dimensionally consistent, can still be wrong because you could have any constant there and which would preserve its dimensional consistency. Okay, so let's look at A. So is this dimensionally consistent? The dimension of V square, is it equal to the dimension of 2AS? Okay, the dimensions of V square are L square by T square. The dimension of V is L over T, and so since it's squared, it's L square over T square. Is this equal to the dimension? The dimension 2 is just a number and it's dimensionless. Dimension of A is L over T square, and the dimension of distance is L. So L over T square times L. And so which is equal to L square over T square. So dimensionally this is consistent. All right, let's do D. All right, let's do B and then we'll do D. Okay, so S is equal to VT squared plus half AT squared. All right, the dimension of S, is that equal to the dimension of VT squared plus the dimension of AT squared. Okay. All right, 0.5 AT squared. That was sort of redundant because the 0.5 is the number and it has no dimensions. Okay, so the dimension of S is length. Is this equal to the dimension of velocity is L over T, and that's T squared. Okay, so L over T and T squared. So we don't even need to go any further because this is this is L times T, and that's not equal to that. But anyway, so the dimension of the second term is the dimension of, this is dimensionless. The dimension of acceleration is L over T square, and then that's T square. Okay, L over T square times T square. Okay, so is L equal to LT plus L? So this term is not consistent, so this term has the wrong dimensions. So this equation cannot be true. And that's the whole point. All right, I guess we'll stop right here.